everybody. We are the group we're supposed to represent the optical properties of LED, but the topic is too large, so we narrowed it to optical properties of photonic crystal-assisted LED. So my name is Li Jianwei. I'm from the Graduate Institute of Electronic Engineering, and this is my partner, Grau. Would you like to introduce yourself?
Hello, I'm Cuauhtemoc Hernandez. I'm exchange student here from Canada in Montreal, and my major is engineering physics.
Okay, so next. And here is our outline. Is quite simple, so let's get started. This is the main article we are going to talking about. The title is Directional Emission Control and Increased Light Extraction in Gallium Nitride Photonic Crystal Light Emitting Diodes. And these are the authors, and they are the WHO research group and WHO research group. And these are this table is their structure, and their lab are mainly doing nanophotonics, solar energies, and also bio-inspired materials. And they are from material departments of University of California, Santa Barbara. And actually, this article is a little bit difficult. Actually, Carl and I discussed almost every day last week, but we still have made misunderstanding. So if you think we are not correct, you just correct us. Yes, welcome. So next. First, I will get started with some easy part. The total internal reflection. I hope everybody still remember this. If you have a LED without any other ways to extraction the light, they are only about the percentage of 1/4 n squared per surface. So next. And there are some other ways to extract more light. Such as the first graph, that is surface roughening. Okay, and the second is geometrical modification. Geometrical modification is like such as a TIP structure. I think the teacher already told that. The main purpose of geometrical modification is that they want to reduce the mean length for the photon in the crystal. Okay, so now you can see that these two methods have a major drawback. Is this method relies on random light redirecting effects. So what about this work? And in this work, the author used gallium nitride LEDs, which is assisted by photonic crystal, and also index guide layer in the vertical direction. The increase in directional emission comes to 3.5 times of the non-photonic crystal case. And is that impressive? Yes, it is. Next. Compared to the previous work, the improvements only limited to 1.5 to 2 times. It is because of these two major reasons. Because in previous work, they use optimized vertical design that does not achieve maximum interaction of the guide mode with the photonic crystal, and also they not use the optimal lattice constants. So later we will show how this work improves these major drawbacks. So and now Grau will introduce something to you.
So I'm going to explain the working principle of the LEDs with photonic crystals. Since this is more of extraction light field, I'm going to go quite quickly through this. So here we have the diagram of LED with photonic crystals. So they make holes here in the PGAN. They make holes here in the PGAN, and the PGAN with the holes is called like a photonic crystal. So usually the light, without the photonic crystal, the light is emitted here from the quantum well, and Some of the light goes out, some of the light goes to the sapphire. Okay. So yeah, usually the light is emitted. Yeah. I'm gonna use my fingers here. Usually the light is emitted here. Some of the light goes to the air. Some of the light goes to the sapphire. But most of the light is trapped inside the GAN. Actually, 66%. So the GAN acts as a waveguide for the light, and the light propagates inside the GAN. So when we have photonic crystals, the light propagating inside the GAN is diffracted by the photonic crystals to the outside, and that's how we manage to extract the light from the GAN. So we can see in that picture over there, the one on top has no photonic crystal, and the light is quite uniform. And the one in the bottom here is LED with photonic crystal, and we can literally see that the pattern of the holes here in the photonic crystals in the light. So the one with the photonic crystal emits more light. Next. The structure of an LED with photonic crystal is very much the same than a normal LED. The only difference is that they add obviously the photonic crystal here on the top in the PGAN, and also in this article they use extra layer here. So as I said before, most of the light is trapped here in the GAN. So the GAN acts as a cavity, resonating cavity, and there is many modes resonating.